This is the golden rule of measuring. 1 decimal point more than the tool shows. If you take any notes today, it's that. This is one of the most important set of notes I can give you in this early year. Whenever you measure anything, you should estimate 1 more than the tool shows, except in one case, and that's if you're using an electronic tool, because it does that for you. Otherwise, you estimate 1 more than the instrument has. Again, that is super important and should totally be written down. Starred, circled, whatever. And that is measuring. Now, let's talk more about that. This fact, by going one place more than the tool has every time, is also a way for us to know how good was the tool that was used to make that measure. A better tool will have more places. A worse tool will have less places. If we follow this rule, it will tell us how good the tool is and how trustworthy the measurement can be. We're going to be talking about that a lot over the next couple days. Now, for electronics, there's no estimation. The tool does the estimation for you. Whatever it says, you write down, but you still need to make sure you have the right amount of decimal places. Whatever the tool says, write it all down. Liquids, you have to watch out for something called the meniscus, which is the bulge. Every liquid has a bulge, basically, and you need to take that into account. The 2 liquids that we measure the most in chemistry are water and mercury. Mercury is assumed to be in thermometers and water for everything else. As you can see, this first one is water, and water bows downward. Okay, and you want to measure the very bottomiest bottom of that. So when you're measuring water, you want to measure the absolute bottom of that bulge. That's where the water actually is. Because water is sticky. It likes to cling on to things. I mean, you know this. If you've ever had water droplets, notice how they stick to you? They can even defy gravity at times. Yeah, water is sticky. So it will grab onto the side of whatever tool it is. So you have to measure the lowest part. For mercury, it's the opposite. It bows up. Mercury doesn't like most things, so it doesn't stick like practically anything. As such, it will bow upwards, and you want to measure the highest part of that bulge. So bottomy is bottom for water, tippy is top for mercury. So that's what the meniscus is all about, in the direction of the bulge. So now, when we sit there and take a look at it, when you get a new tool, you should identify the units that it used right away and write those down. Units are important. Then look at what values it has printed on it, and that includes the dashes. So you want to check the numbers that it has, then you want to check the dashes. And last but not least, you want to estimate 1 more value than the tool shows, because that is how you measure. Always estimate 1 more than the tool shows. We're going to do some virtual practice on this. There are 2 rulers. Which ruler is better? Ruler A or ruler B? Talk it over for 10 seconds or whatever. And please tell me why it is better. All right, Miss Fitzhenry, what do you think? All of that you just said perfectly. You said not accurate, but precise. It's more precise because it has more lines. Perfect. You'll also notice this little sidebar statement. I will do this a lot when I'm not, like, I'll do this for my slides. You can imagine me telling you that part. You'll see those on a lot of slides. So always check the sidebars. That's like me talking to my audience. So there it is. So you are right, ruler B. And now notice it changes. Due to there being more dashes, it makes it 10 times better. More dashes means we have another decimal point. Every decimal point is 10 times better. So B is 10 times better than A. But let's take a look at A. We're going to just focus on that for now. If we look at A, and because it's digital, I could just draw a line here. The tool tells us 2 centimeters. It doesn't quite go to the 3, doesn't even go to 2.5, but it does go past the 2. So we know it's 2. We then have to estimate one more than that. Now this is 2.5. So what is a good estimate for this? Talk to your group member, see if you can figure it out. Go for it. Right now, 10 seconds. Mackenzie, since you don't have a group member, since he went to soccer practice or whatnot, if you want to lurk near another group so you can talk to them, if not, you can just chill in the back and I'm fine. Whichever is more useful to you. Because I do prefer there to be as little contact as possible, but, you know, talking is important. So, here we go. All right, Ashton, welcome back. What do you think is a good estimate here? The next digit. 2.2. Okay. Who here agrees that 2.2 is a good answer? Just show of hands real quick. Okay. All right, people who didn't have your hand showed. So let's see. Trinity, do you have a different answer? 2.2 is good? Okay, so we all agree 2.2 is good? All right, now, is this an estimate so we can be a little off? Do you agree with that? So 2.2 is fine, but it says here, estimates can be different. The plus or minus 1 on the last number place is acceptable. So I put 2.2, but if you put 2.3 or 2.1, would you be correct? Yeah, you're allowed to be off by 1 on that very end. So I said 2.2, you could have 2.3 or 2.1. Now that's not always the case. Sometimes the answer is very clear, especially if it's on the line, but sometimes there's a little bit of give. So let's look at the better tool. Same nail. We're now here. The tool is now telling us 2.1. Now, if we look at this, that line isn't at the halfway point, is it? Do you see how there's more white space before than at the end? So that means it's above 5. If it was right in the middle, it'd be a 5, but if there's more white space before, that means it's more than 5. With that idea, what is the measurement of this second nail? Talk it over, 10 seconds. I already know who I'm calling on. So right now, it could be you. All right, Mackenzie, what do you think? I agree. I think that's an excellent estimate there. Would I accept 2.16 and 2.18? Yep, remember, you're allowed to be 1 off on that last number, as long as it's not on the line directly. So yes, 2.17 is what I think it is as well. 2.18 or 2.16 would also be acceptable. All right, we've now got 3 rulers, the crappy ruler A to the really good ruler C. Okay, now we're only going to look at ruler A for now, and I'm going to put a line there. I would like you to talk to your group member and figure out what that line measures. Again, assume we're starting at the 0 and we're measuring to the 10. That's where the line is. Where is that line? Talk it over with people around you. Sophia, what do you think? Now hold up there. 1.5. That gives us another decimal point there. I think 1.5 is a little too much. Also, you're going to want to avoid all fractions. Fractions are actually a beast when it comes to measuring because of what we'll get into in the middle of the week. So try to avoid halves and thirds and fourths and whatnot if you're taking a real measure. All right, so let's check there. Ms. DiMarzio, what do you think? Probably like 1? Okay, 1. That's not bad. How many of you agree that it's 1? We got a couple agreement. Do we have anybody who wants to say something else? Joseph?
2.
Okay, 2. I like 2. Does anyone think 3? So you're thinking 1 or 2. Okay, I got to admit, I like 2. And of course, I'm going to put centimeters there because we always need our units. So 2 centimeters, I like it. 1 is just as fine because again, it's the only thing we have is an estimate. We don't have any number that the tool gives us other than 0 and 10. We know it's not 10, so that means the 10th place is a 0, and we tend not to write that, so we're not gonna. Now, this is a better tool, and you can see more clearly that 1 was a better answer than 2, even though 2 was not bad at all. The tool tells us 1 centimeter, but we can go 1 further. To that effect, Jamie, what do you think? 1.3. Do we have any agreement with Jamie? Hands up real quick if you agree with Jamie. All right, I got some agreement. How about 1.4? Got some agreement there. 1.2. We've got agreement there. I like 1.2, 1.3, and 1.4. Now I mean to change this to 1.3 because I think 1.3 is even better than 1.2. All right, but that's okay. 1.2, 1.3, 1.4. Now, that's hard to see. If you have your device out, it's probably really easy to see. Of course, if you had your device out, you may have clicked a couple extra times to see what the freaking answer is, but that's fine too. All right, because as we get here, the tool is telling us 1.3. Straight up saying 1.3. We then have to go 1 further, but that is a pain in the butt if you're looking at my board from your seat. But if you're looking at this from your screen, do you see how much closer and how much easier it is? Should you ever take measurements from several feet away, or should you take them where they're pretty much next to you? What do you think, class? Where they're next to you. Very good. So make sure you take your measurements close. So I have 1.33 here. And the reason for that is it's closer to the 3 than it is to the 4. So it's not going to be 1.35 or higher. It's going to be less than that. So, but it's also not right on the line, so it's not 1.31. So 1.32, 1.33, 1.34. All of those are perfect. Do you understand how this goes? Do you have any questions for me yet? Let's make another line. Nicholas, ruler A. What measurement? Ruler A, red line. 4 or 5. I like it. 4 or 5 work in centimeters, right? Very good. So 4 or 5 centimeters. Either of those would be perfectly fine and accurate. Okay. Trinity, how about the second one? 4.5. Yeah, that looks pretty solid there. It really does look like it's the middle. Now, here's a neat thing. Whether you know this or not, human beings, our eyes are freaking great at finding the middle between 2 points. Your brain typically is very good at finding that middle space. Use that to your advantage. Always look for the middle and decide, is it beyond the middle? Is it before the middle? Is it on the middle? That'll help you read better measurements. And once you get your brain trained to do that quickly, you're golden. Everything will work out better once you train yourself to rely on what your brain is already good at, which is finding the middle ground. Now, as we look to the line below it, we have an issue. Notice the red line is directly on that line there. So what do we do? Well, the tool says 4.5, right? But do we need to go 1 digit further? Yes, every time. So what digit do I put there if it's right on the line? 4.50. 4.50 is the correct answer for that. Now, this doesn't have variance. It's right on the freaking line. There's not a lot of wiggle. That's right there. 4.50. How about this line here in green? Look at that. Take a minute. Maggie, what do you think about A? Very good. And Maggie, what do you think about B? Uh-huh. And how about C? Perfect. That is all perfectly correct. Now, you might be like, wow, that's odd. But it tells you that in science, if you're given the number 8.00, isn't that more trustworthy than just saying 8? In fact, it's 100 times more trustworthy. When we talk about trust in numbers, that's a big part of what we are going to do on Wednesday, which is significance. I'm going to expect you to have lots of questions once you do your virtual lesson on Wednesday. So if I see you on the office hours on Thursday, or I see a bunch of emails, I will not be surprised, because that is what I expect for Wednesday's lesson. But this is where it comes from. Notice that the tool tells us the decimal places. No decimal, 1 decimal, 2 decimal. And it's also telling us the trust then. Trusted numbers are significant, and we're going to talk about that more on Wednesday. So that's our little our measuring lesson. Now, you have got all of these beautiful practices here that you have. Each of these practices, you can look at the tool, you go to the blue, you check, okay, this is in centimeters, and it's 30, 31, 32, which means my dashes are 31.1, 31.2, 31.3, 31.4, 31.5, and then I estimate. Now this line is just a little above the middle. So if 5 is the middle, a little above 5 is 6 or 7. So I've got 31.57, 31.56. Either of those will work well. Now the violet one, we've got 30. Then that's 30.1, 30.2, and this one's a little above the middle as well. So we're at 30.2, 30.27. If I go to green, it's right on the line. So I've got 32, oh, and it's right on 32. So that's your 32.00. Now red's a bit trickier. We've got 30, 30.1, 30.2, 30.3, 30.4, 30.5, 30.6, but it's right on that line. So if it is right on that line, Francis, what is it? If it's right on the 30.6 line, and I need to go one place further, what's the answer? Yeah, 30.60. And that's harder. Now these ones are all set to easy to hard, blue to red for these ones. So I'm going to go through these a bit quick, if we do have the time. Also notice all these measurements have 2 decimal places because it's based on the tool. Every measurement from this tool should be 2 decimal places. All right, new tool. We're dealing with thermometers. Now watch this. This is 0, 10, 20. Ah, crap. This means the dashes are not decimals. The dashes are our ones place. 0, 10, 20 means that these dashes are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, 12, 13, 14, 15, etc. So the tool changed. We need to be aware. Since this is a thermometer, we have to assume it is mercury, so we go to the tippy top. I've got to 10, 11, 12, 13, 14, 15, 16, and then it goes not quite to the midpoint, just shy of it. So a 16.4 Celsius. If I go to my violet, we're at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we'll see that it's not quite as high as our 0.4 earlier, so we're at 9.3. Now green is right on the line. So that makes our life easy. 20, 21, 22.0, because it is right on the line. Now here's the kicker, and that's red. Red is negative. You only get that with temperatures. Count backwards. Start at 0, -1, -2, And then it doesn't hit -3. It goes to the tippy top of that. So we're not -3, we are at -2.6, as it is a bit further down there. Because remember, we're counting backwards as we go. It's closer to the 3 than it is to the 2. So -2.6. And be careful, count backwards for your negative temperatures. All right, and every one of these measurements has 1 decimal place because that is what the tool says. Now, sorry about that, that happens. It skips every now and then. All right, so here, remember, we're dealing with meniscuses, liquids. We measure in the direction of the meniscus or bulge. It means underestimate or overestimate in that direction. The tool says 234, which means we have to estimate our first decimal place, and there are no dashes. So for blue, I go to 3. I go up to the very bottom of this, and I get 3.5, 3.4, because it should be lower, not higher, and that's pretty much in the middle. For violet, I go up. It's bigger than 2, less than 3, very close to 3, and it bows upwards. So I want to measure at the very tippy top, not where it hits the side, but the very tippy top. So I'm at 2.8 or 2.9. Green is right on the line again, bowing down, so it should be 2.0. But red is our quick talk here. Red doesn't have a bottom line. Do you see that? Do you see how there's no lower line to measure red off of? Well, that stinks. Measuring without lines on both sides is bad. Do your best, but you probably should get a different tool. It winds up being about 1.7, but we shouldn't even use that tool because doesn't have lines on both sides. All right, again, everything's to 1 decimal place, and there is your practice.